This is a short presentation on nylon as a polymer and Kevlar. Here I've mentioned three polymers of nylon. So this is a short scenario to make you get an idea of the different materials that are made of nylon. So just imagine this. You wake up in the morning and get out of bed. You hop across your carpet, and while doing so, you notice a little tag sticking out of the carpet saying that it is made of a certain percentage of nylon. When you enter your restroom, and apart from the other things that you carry out in the restroom, you get to brushing. While doing so, you notice that the bristles of the toothbrush are also made of nylon. Before heading out, you grab an umbrella, as a forecast predicts rain later in the day. The material of the umbrella also being made of nylon. Lastly, you get into your car, and before you buckle yourself in the seatbelt, you feel the material, and it feels kind of tough yet smooth, so you wonder, could that be made of nylon? Fun fact, older versions of car used today did have nylon seat belts. However, now they're made of polyester. Speaking of fun facts, did you know that the flag taken to the first moon landing is also made of nylon? In fact, parachutes made before World War, the parachutes were made of silk. But during and after the war, parachutes are made of ripstop nylon that is woven into a double or extra thick thread at regular intervals, creating a pattern of small squares. This structure keeps small tears from spreading. Nylon is also waterproof, water resistant, fire resistant, and tear resistant with zero porosity, which means that it does not allow water or air through. Not to mention cost effective, being $4 to $8 per yard. So in this presentation, we are going to discuss what is nylon and how is it made, some of its properties, nylon as a polymer, 666 and 610, and Kevlar. So what is nylon? Nylon is a tough, lightweight, elastic, synthetic polymer, and we'll define what synthetic is in the next slide. Made of polyamides, don't worry, we'll tell you what polyamides are as well. This is a thermoplastic made of petroleum. Thermoplastic being something that you can heat and then cool and then mold it into whatever different shapes, filaments, films, sheets, etc. So, nylon is a synthetic polyamide, not a natural polyamide. Polyamide is a polymer with repeating units linked by amide bonds. And an amide bond, as you can look, to the lower left corner of the slide, you can see what an amide bond looks like. A synthetic polyamide is made through a condensation polymerization, and we'll tell you what condensation polymerization is as well. So, condensation polymerization is characterized by monomers that contain two different functional groups capable of reacting with each other. As you can look to the upper left corner, this illustrates the two different functional groups capable of reacting with each other, and this leads to the formation of small molecules such as water, H2O, or HCl. Okay, so this is discussing the nylon's polymer 610, and if you look closely at the reaction happening over there, we have two monomers of one consisting of hexamethylene diamine and the other one being carboxyl chloride. So if you look at the first monomer here, we have hexamethylene diamine, and what's going to happen is that one hydrogen from the hexamethylene diamine is going to bond with the Cl on the carboxyl chloride, and this is going to be disposed of or created as a byproduct, and it will no longer be part of this reaction, and then you form a amide linkage right here. If you go back to right here. You can look at the, if you look at the left, lower left corner, you can look at the amide bond and just identify the amide bond created over here. If you want to further go ahead and watch the synthesis of nylon, this is a very fun short video on the synthesis of nylon. I will link it down below. It's a YouTube video and it is very informative. In fact, if you want to recreate this for your school project or to show your students or just for fun or to see for yourself what it is, you can recreate it as well. So let's move on to the second polymer of nylon, which is nylon 6. We have the monomer caprolactam, and it is a ring structure that needs to be broken down by water. If you can guess what this process is known as, I'll give you a few seconds. So, breaking this ring structure of sorry, slip of the tongue there, caprolactam, we need water to break it, and this process is known as hydrolysis. And after breaking the ring structure, we have the open form of caprolactam, which is amino caproic acid, which then, by adding water, by polymerization, we get the nylon 6 polymer. And polymerization, keep in mind, is the act of monomers joining up to create a polymer. Nylon 6 is also known as a homopolymer. This is because we only have one monomer to start off with, which is the caprolactam. If you go back to our nylon 610 polymer, we had two different monomers. However, in nylon 6, we only have one monomer. So let's move on to the next polymer, which is nylon 6,6, and this is a similar reaction to nylon 6,10. Here we have the two monomers 1,6-diamino hexane and hexane dioic acid, also known as adipic acid, and H and HO. Just look at the reaction over here. The H and the HO, which is in a box, is going to join, and then it's going to be disposed of, where or it's going to be known as a byproduct, and then we have our amide linkage that is going to be formed. Let's now move on to Kevlar. Kevlar is a very strong synthetic fiber and is similar to nylon, not exactly the same, but similar. So let's discuss the bonding in Kevlar. The attraction that holds the polymer strands together works on a principle similar to electrostatic attraction. The difference is that polymer strands of Kevlar are held together by hydrogen bonding. Kevlar has a highly crystalline structure. It is strong covalent bonding in the fiber direction and weak hydrogen bonding in the transverse direction result in a highly anisotropic properties of Kevlar fiber. Its strength comes from strong intermolecular forces between adjacent chains of the Kevlar polymer. This strong intermolecular force is called hydrogen bonding. The electromagnetic attraction between some hydrogen atoms in one strand and the oxygen atoms in another. So, why is Kevlar so special? It's strong, but it is relatively light. That's why you can also use it in those Kevlar gloves. It's easily wearable. It's good at withstanding high and low temperatures. It has a high chemical resistance and it has tensile strength 10 times greater than that of steel. So it's commonly also used in bulletproof vest, combat helmet, bicycle tires, and fireproof clothing. A fun fact about Kevlar is that it's usually also asked as a question that can Kevlar withstand a bullet? Kevlar is an excellent anti-ballistic, which means bullet and knife resistant material, because it takes a great deal of energy to make a knife or a bullet pass through it. The tightly woven fibers of highly oriented or lined up polymer molecules are extremely hard to move apart. It takes energy to separate them. And it's kind of similar, if you recall a bit, to nylon, where it was woven as well into a thick thread so that especially when we discussed in the parachute material, it stops the tears to spread. So I've talked through the whole presentation about nylon and its excellent qualities. However, nylon is non biodegradable, which means that it is absolutely the worst for our environment. So let's look at some of the ways how it affects the environment. Nylon is non biodegradable and will persist in the environment indefinitely. Nylon fabric takes 30 to 40 years to degrade, and if you compare it to some other materials that have known to take 1,000 years, for example, Coke bottles that will take 1,000 years estimated to biodegrade, um, nylon doesn't seem to compare that much. But if you look at how readily nylon is being worn in athleisure or other fabrics, then you might be able to imagine the pileup of nylon fabric being used. And another fact is that fishing nets and synthetic textile fibers are the largest source of microplastic pollution. It greatly impacts aquatic life significantly. So while nylon is greatly advantageous, it is cost effective and it is a very nice tough material. It is not the best for the environment. In fact, it is very, very bad. And here we have a little activity time. You can screenshot this, and it's just a small little quiz that we came up with. So hopefully this video was somewhat informative. Thank you for watching, and that's about it.